Hi guys, this is the narrated version of my experimentation with the CD error checker board used at West Chester in production of the CD32, along with all these other bits that plugged into this parallel multiplex board and then plugged into an Amiga test station. I had to connect it to a parallel ribbon cable and then had to find a connector which was provided as a sample. Okay, keep your eyes here on this LED bar graph display while I turn it on. And it's just a little startup demo. It's all coming from the microcontroller to test all 8 segments of the display. There's only 8 of 10 connected to display a byte. And this is the 4-bit parallel output, which is simulating the CD error signals going into the board here. This button here is an input to the microcontroller, and it affects the microcontroller only feature of turning off the simulated output that would be fed into the board. That's the part that would normally come from the CD controller. I don't really even know which particular sequence of events triggers is interpreted as an error. I just know that I am cycling through it. I can narrow that down later and find out. And the board wouldn't be counting if I pulled that out. The next 2 buttons here tell the microcontroller to turn on and off the select and busy pins that are on the parallel port. They're the only 2 control pins that are inputs to the error board. There's an 8-bit output through the parallel port, which is what's displayed on the bar graph. In future, I'll have this real-time 1 second interval counter operating as a gate time to reset the microcontroller, or not the microcontroller, to reset the error board. Yeah, I'd find this one interesting. So it looks to the output doesn't need to be latched, it's always constant, so it holds it for a while and resets, which is typically a frequency counter would latch and reset. This one seems to hold it, give you time to read it and then reset. We'll start it again and bam. So it could possibly be that the Amiga just start for a period of time, stop, read the outcome, start, stop, read the outcome before it resets, and then over and over again. Essentially seems to be what's happening, but I'll need to align that with the 1 second pulse, which I haven't done yet, and then all you'd see is, well, I don't know if I can actually do it in a second, it might overflow before that, but for whatever period, it looks like the Amiga, or whatever program's controlling it, whether it's this or the Amiga, boom, boom, and you just have a cycle of boom, boom, and if the error rate was constant, which it is going to be when I implement it, well, still with the simulated output, we'll get the same value on the port every time. Sony's datasheet for the CXD2500BQ DSP chip for CD players. That's a mouthful. When I say I don't know what constitutes an error for the error board, I don't really know what it's looking for, but Sony spell out the output of the 4-bit port. There's a couple of values here that meant there was no error detected at all. That's these 2. And there's a couple of values that meant an uncorrectable error. And then everything else, you can have 1 error, 2, 3, 4, they're corrected, but that's 1 value representing 4 errors, so I don't know if the board's smart enough to make a count for every error rather than just a value. I suspect it can over time. We do see a change on the 4-bit port. As we're moving a long time, we've got 1 change, 2, 3, 4, so it could be doing that. I read that a new drive or a good condition drive will have up to 220 errors per second or 10 seconds, I'm not sure which one, and I guess that would worsen as the condition of the drive is worse. So for testing new drives, I suspect they were looking for every read error. In a normal state, counting like that, It's the busy and select pins on the parallel port that are, one of them's actually normally high and one's normally low. I can't remember which is which, and I don't even know right now which one of these buttons is which. But what you won't be able to see now is with that beeping, which I can turn off. What I think would have happened at the Commodore business end is every period, which is faster than I'm going to press it, is start the counter and stop the counter, and then it resets. Start again, stop, look at that value, then it resets. While I'm writing it, I might find out something more intuitive than that they might have intended. So I'm not really sure, but what I will know is the actual error rate, so I'll be able to read back what makes sense. So I kind of, at a stage, I do know I'm going to get it right. For the board I did to interface with the error board, it's a 16 F877A, a pretty old 8-bit chip with a lot of ports. It reads the parallel data from port B and then inverts it for the display. So for every cycle it'll read, invert the byte, and then send it to port D. It has to invert it because these are connected high. The port D sinks current for the LEDs to work, so they're in an inverted state. The 4 bits to display the output of the CD error simulation is port C. These are the upper bits of port C. The actual output for the CD error simulation is the first 4 bits of port C. So it'll just output the same thing on port C in bytes 0, 1, 2, 3, 4. Oh, sorry, 0, 1, 2, 3, and then 4, 5, 6, 7. The buttons that control the pins are just polled. Simply adjust the pins. Though the gate timer is now doing that automatically, you can still butt in and do it. Same with this button, has nothing to do with the parallel port. That's the one that in software just turned the CD error simulation on and off. piezo buzzer is connected straight to one of the port pins, probably one of port E. Port E is a port where you only get about 3 bits or so, and then the rest of the speaker switch is just a hardware speaker switch to cut off the speaker. 2 and 3 are spare switches, probably again connected to port E, and I'm running it at 10 megahertz. That's probably all there is to know. Okay, now it'll work sort of like a frequency counter should. So I've implemented a gate timer, which is 1 second at the moment. So it'll count the errors, or it'll take a count from the board every second and then reset the board to start counting, which is why the count is always the same at the moment, because I'm not changing the error output. It always just rolls. So we get what is 50 in binary. I can change the duration of the gate timer to 1/10 of a second by doing that. Too fast for me to read in the display, but software could certainly do it, and we get a lower count because we're only counting for 1/10 of a second, obviously. Back to the 1 second. In either mode, the high-pitched tone that you hear is just represents every 10 seconds, or every 10 units, so it'll be every 1 second in the other mode. Again, if I pull the input to the board out for the errors, simulated errors, the next count will get nothing. It will continue to get nothing until I plug it back in. Or alternatively, turn the errors off in software. Now, since the output for the board is a parallel port, it would seem more fitting to write the software for an Amiga, especially since mine has parallel ports, and also it seems like it would be much cooler that the unit under test is the one running the test board. Both my Amigas have SX1 expansions, and that gives them the parallel ports. This one isn't connected because I just have no room on the desk, But since both the CD drives read recordable discs and originals very well, I don't really have any desire to connect them, but I do think I should commit to writing the software for the Amiga in future. So if you've watched my videos, or particularly if you're a subscriber, you probably know that means this board's no longer required.